Hi, I'm Marie. I'm a graduate student at Harvard University working in Victoria D'Souza's lab. And today in this video, I'm going to be teaching you about the basics of centrifugation used in biology. The basic principles behind centrifugation involve rotation around a single axis. This creates a rotational force that goes in the direction of a circle. So if you imagine my center of my axes is in my hand here, and I have a circle of rotation, I have a rotational motion that's following the direction of the circle. The accelerative force that's created is shooting outwards, perpendicular from the circle from all directions. This allows all of my sample to eventually gather at the very end of my tether, at the very end of the tube. Centrifugation in biology is used for several different purposes. We like to use it to gather all of our samples together. We also like to use it to separate out particles within a single sample. Today we're going to be using a basic tabletop centrifuge. When I approach a centrifuge, I can open it using this open button over here, which exposes the main body where the centrifugation happens. Usually there's a little screw top lid that sits on top of this, which when you pull open, you'll find the areas where all your samples are actually located. The other part of the centrifuge to pay attention to is the menu body here, where all your different settings are controlled for your centrifuge. The first one is time. You can see I have it set to 30 seconds right now. I can also increase or decrease the time as I see fit. I'm going to leave it on 30 seconds. The other setting to control is the speed. The speed, the important thing to take note of, is the unit that you can see right here, which is in RPM right now. There's two different speed units, and the two units are very different from each other, so this can drastically affect your experiment if you're using the wrong one. You have RPM and RCF. RPM is measured in terms of revolutions per minute. So if you imagine I start here on the circle, I go all the way around 360 degrees, that would be one revolution around my circle. So RPM is really just measuring how many revolutions around the circle my centrifuge is making every minute. But you can imagine to get the same amount of force, a different centrifuge with a different radius or a different size might have a different revolution per minute, which is why we use this other unit, which is called RCF, in order to give you a more uniform unit between which you can measure different centrifuges. RCF is relative centrifugal force and measures everything relative to G, the gravitational force, which is also why in your protocol you might sometimes see this written as times G. The first application of centrifugation in biology that I'm going to show you is the collection of samples at the bottom of your tube. You can see here I have my sample of blue liquid. If I shake up my tube, my sample will be dispersed throughout the tube. When I'm working with such a small volume, these tiny droplets will actually take up a more significant ratio of my total amount of sample and can actually make a big difference in my experiment. And so I'm going to want to collect all my sample at the bottom of the tube. When you're loading your centrifuge up, the important thing to pay attention to is that you load your samples in a balanced way around the circle. This means making sure that the weight is evenly distributed throughout your centrifuge. As I've loaded this right now with just one single tube, it isn't distributed. All my weight is concentrated on one end of the centrifuge. For a little tabletop centrifuge like this, it may not be as important, but as you do more centrifugation at higher speeds, the tiny differences in volume will make more and more of a difference. If I only have one single tube here, what I can do instead is make a balance to balance it out. And I can do this with something as simple as water, where I just take a volume of the approximate same volume, stick it into another clean tube, and pop it right opposite of my original sample in order to balance my centrifuge out. And then it's important to tighten on the lid so that your sample won't leak around the centrifuge if anything breaks. Close it, and then we can start our run. When my centrifuge finishes running, you'll see that first I have my blank, which is still there, and then my sample has all collected at the bottom of the tube. There's no more blue on any of the surrounding areas of the tube, and this is exactly what I'm looking for. The second application of centrifugation that I'm going to show you is separating different particles of different weights within one single solution. I have here a sample that I prepared which is a sample of some bacteria. And all of the bacteria is currently suspended in the solution. What I want to do is separate out this bacteria from the liquid so that I can resuspend it in something else. I'll pop that into my centrifuge, again with my balance that I've created. And then I can screw on my lid and start the centrifuge once more. When my spin is done, I can unscrew my lid again. And I can see here, and you might be able to see the contrast better against the black gloves, where I created a pellet of the cells, of the bacterial cells at the bottom, with the liquid supernatant on the top. I don't want the supernatant for the purposes of my experiment, so what I can do is take a pipette tip and be very careful about removing the supernatant just from the top without disturbing the pellet at the bottom. I'll put the supernatant into my waste tube over here. You want to make sure you don't put your tip all the way to the bottom where it's going to touch the bacterial pellet, but just let it skim gently at the top while you slowly remove all of the liquid. Just like that. This will leave you with a nice, clean pellet at the very bottom, free of any supernatant. This concludes the video on basic centrifugation. There's many more applications for centrifugation that you'll discover as you continue in research, but here we've just shown you the most basic fundamentals.